Let's look at number systems. And our question says find the HCF and LCM, right? But we are interested in looking at the HCF for now. Let's look at the HCF, right? Find the HCF. HCF simply means highest common factor. Highest common factor means the largest number that can get into any given set of numbers. And take note, when we're finding the HCF of two numbers, we're going to divide the given numbers by prime numbers only. I'll repeat, we're going to divide the given numbers by the prime numbers only. And don't forget our prime numbers. I can just try and list down a few. The first prime number is a 2, followed by a 3, followed by a 5, a 7, 11, 13, 17, 19, 23, so on and so forth. And prime numbers, like we covered in our previous lesson, it simply refers to that number that is two factors only. Numbers that are divided by two factors, that is 1 and itself. Let's get back to business. Let's find the HCF of 12 and 18. This is how we do it. I'll put a line here. I'll write my 12 here, and I'll write my 18 here, right? And then on this side here, that's where I'm going to write my prime numbers that are going to divide, right? Take note, we're going to divide by prime numbers only. I have a number 12 and an 18. I will look for one single prime number that can get into 12 as well as 18 without leaving a remainder. One single prime number, right? The first prime number that to go into this number, these numbers, is a 2. So I will divide, right? I've identified a 2. So I'll say this 2 into 12. What do we get? 2 into 12, or 12 divided by 2. What is the answer? The answer is a 6, and I'll write the answer here below the 12. It's a 6, right? The same 2 into this 18. What do we get? 2 into 18, or 18 divided by 2. We get a 9. I'll write a 9 below the 18, right? In other words, we've identified the first prime number that can go into 12 as well as 18 without leaving remainders. So I got the answers, a 6 and a 9. I'll again look for a single prime number that can get into 6 as well as 9 without leaving a remainder. What is that prime number? 2 can no longer go into 6 as well as 9. So I'll look for a single prime number that can get into 6 and 9. That number is a 3. A 3 is a prime number. So we'll divide by a 3, right? 3 into 6, what is it? This is the same as 6 divided by 3, we get a 2. I'll write a 2 here, right? The same 3 here into this 9, right? 3 into 9, or 9 divided by 3. What is the answer? The answer that we get is a 3, right? We now have two numbers, 2 and a 3. There is no single prime number that can get into 2 as well as a 3, right? Like we did in the other numbers, a 2 and a 3. We cannot identify a single prime number that can get into these two numbers, a 2 and a 3. So when we reach this stage, we are done. We can just end here. So these two, product of these two is our HCF. Take note, product of these two numbers is the product of these two numbers is our HCF. So we can simply say HCF of these two numbers, 12 and 18, is equals to 2, which is this here, multiplied by 3, which is this here. And the answer that we get is our HCF, which is what? A 6. This method is fairly simple. I'll just offer a brief recap. You divide by prime numbers. common prime numbers that can get into the given numbers are the numbers that we are looking for. We find the product of those numbers, and the answer that we get is our HCF. Can you try the same method and work out from number 1 up to number 10? Thank you very much.